Hello, so today you are comparing two population parameters, and we are going to be using confidence intervals to compare these two parameters. So this is textbook section 10.1. Please go there to look on for extra examples and practice problems. So we're comparing two portions. So if I think about some notation and kind of think about this big picture before I put calculations to it, I'm going to have two populations, population 1 and population 2. Well, each population has its population proportion, or the true percent of the population who meets some characteristic of interest. So you have population 1, it has proportion P1, population 2 has the proportion P2. Well, from these different populations, I'm going to take different samples. So my two sample sizes are going to be N1 and N2, going with their respective population. So remember, I don't want everyone in the population, so I take samples because they're easier to analyze. Well then, from my samples, I'm going to end up getting a sample proportion, or P hat 1 and P hat 2. And these two numbers are where most of my analysis is going to come from. So P hat 1 is the sample proportion, or the sample percent that I got from sample size 1, which I took from population 1. So what I'm doing is I'm trying to compare two proportions by giving a confidence interval for their difference. So I want to compare, how does population 1 differ from population 2? So I'm making an interval around their difference, which will be P hat 1 minus P hat 2. So this is the interval that I'm making. I'm saying, what's the true difference between these two populations? So get out your comparing two groups step sheet. So this is a new sheet. I'm not sure what color it's going to be, but the other one was orange. This is not the orange one. This is a new one. So get out this sheet. You should have just gotten it. And let's take a look at these 4 steps. It's the same 4 steps every single time. Step 1 is identify the population and the parameter. For confidence intervals, there's no null and alternative hypothesis, just the population and parameter. Well, then my plan step, I need to verify all conditions. So we're going to go through these 3 conditions on the next slide, so leave a little bit of space right here for these 3 conditions. They're the same 3, random, normal, independent, but we're going to break them down a little bit more now that we have more data to go with. Step 3 is the do step. You have to show your substitution into the formula. Even if you use your calculator, you have to show your substitution into these giant formulas that we're going to create. Lastly, conclude. We have to interpret my results. So what is my conclusion? Give the interval, connect it to the problem with some context. So these are my 4 steps. Break down step 2 real quick. So step 2 is my conditions. So the first condition is a random sample. Well, since I have 2 different samples that I'm looking at, they both have to be random, either from 2 different populations or 2 treatment groups within the same population. This will make more sense the more problems you see, and you see whether it was 2 distinct populations, like I took a sample of people from Virginia and then a sample from Connecticut, or if it's 2 treatment groups, like maybe I took a sample of women and a sample of men. But both have to be random, and that's going to be stated in the problem. The second condition is normal. In order for something to be normal, now I have 4 equations that have to be true, and you'll see we changed this to 5. It's no longer 10. So all of these have to be true. Write this on your new confidence interval step sheet, or your new conducting a test sheet where it says N. Write these in there for proportions because you're going to want to remember these. Lastly, independence. We assume that individuals are independent and that the population is at least 10 times the size of the sample. So this is very consistent with what we've been looking at. So key point number 1, just to kind of hone it in a little bit more, in order for the normal condition to be met, all 4 of these have to be true. So make sure that you check all 4 of these. You have to show your work for all 4 of these. I know that seems tedious, but we have to make sure that I can do inference on these different problems by checking this condition. So once I check my condition, I can then do my calculations. So take a minute, pause this video, and write down this giant formula. Okay, now that you paused it and you pressed play again, let's break down this a little bit more. So this first piece is just the difference in my 2 p-hats. Plus or minus, so this should say proportions, plus or minus z star. Remember, z star is my critical value. It comes from the t star table. And then I have this giant formula, the difference in my standard deviations. Woof, that's a really big formula. But if you look at your formula sheet, so look at the packet that you got on the last quiz, or look at the formula sheet, this is on there. You just have to remember that this is the standard deviation for 2 proportions, and it even says 2 proportions in standard deviations on the row and column of that formula sheet. So this is there. You don't have to memorize it because you'll have it provided, but it will be on the formula sheet, not in this problem setup. So you need to know, like I said, the pieces of this formula from the formula sheet. So these are the pieces, the difference, z star, and then this giant standard deviation, which is really the 2 standard deviations just added together in this confidence interval formula. Like always, you can use your calculator to find the actual interval. So once you show your substitution into that giant formula, you can then do stat, test, 2 prop z int, because we're making an interval, so 2 prop z int. x1 and x2 are the number from the sample who meet the characteristic of interest, and n1 and n2 are the sample sizes, and the confidence level is given in the problem. So this is what your screen should look like if you go to stat, test, and then scroll down to 2 prop z int. You should get this screen. So now that we have the state, plan, do, conclude kind of setup, let's take a look at a problem. So this problem says just before the presidential election in November of 2008, a local newspaper conducted a poll of residents in a medium-sized city and found that 120 out of a simple random sample of 250 men intended to vote for Barack Obama, and 132 out of a random sample of 240 women intended to vote for Barack Obama. Construct and interpret a 95% confidence interval for the difference in proportion of women and men who supported Obama in this city. So if I think about my step 1, my state step, the first part is writing the population. So the population would be all men and women in this city. The parameter is what are we trying to estimate or what are we trying to see? Well, we're looking for the difference in proportion of men and women who supported Obama in this city. So that's all we have to write for the parameter. We want to estimate the true difference in the proportion of women and men who supported Obama in this city. So this is my state step, population parameter. Since it's not a significance test, there are no hypotheses, so we can move on to the plan step. So if I think about the plan, first part is the random. Well, it tells me it was a simple random sample of women and a simple random sample of men. So I can say random sample stated. Well, then the next condition is normal, and normal takes a little bit more work because both of those conditions have to be met. So N1 times P hat 1 greater than or equal to 5. Well, N1, if I think about that being the men, is 250 times P hat 1, which is 120 out of 250, greater than or equal to 5. Well, that gives me 120, which is greater than or equal to 5. Well, then I have to do N1 times 1 minus P hat 1 greater than or equal to 5, and that would be 250 times 1 minus 120 over 250 greater than or equal to 5, and that gives me 130, which is greater than or equal to 5. So I'm going to do the same thing for the second sample, which is the sample of women. So N2 times P hat 2 greater than or equal to 5. Well, N2 is 240. Be careful, they're a little bit different. Times 132 out of 240 greater than or equal to 5. Well, 132 is greater than or equal to 5. And then if I do it for the other one, I know this is long, but it is worth it because then we could do a confidence interval. Well, 240 times 1 minus 132 out of 240 greater than or equal to 5 gives me 108 greater than or equal to 5. So random is checked and now normal is checked because all four of these equations worked. You got to check them all. So last but not least, independence. We can assume voting preferences are independent, and there's more than 10 times 250 men, and there's more than 10 times 240 women. So all of my conditions are checked. Random, normal, independent, check, 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 check. Got them all. Now I get to do my calculations. So this is what we've been working towards. My calculations are P hat 1 minus P hat 2 plus or minus Z star times the giant square root of P hat 1 times 1 minus P hat 1 over N1 plus the same thing for the second sample. So when I go to plug my pieces in, the two things I need to find are what is P hat 1? Well, that would be for men, the 120 out of the 250, which was 48% or 0.48. And for women, or P hat 2, that would be the 132 out of 240, which gave me 0.55. So when I plug these in, I would do 0.48 minus 0.55 plus or minus Z star for 95% confidence is 1.960 times the big square root of 0.48 times 1 minus 0.48 over 250 plus 0.55 times 1 minus 0.55 over 240. Once I showed this formula right here, once I have this, I can stop doing calculation and go to my calculator. So when you type this into your calculator, X1 and N1 I chose for men, X2 and N2 were the women. My confidence level was 0.95. And when I pressed enter, this is the interval that I got. Negative 0.1583 to positive 0.0183. So if I write that out, this would be my confidence interval. So once you have that formula, you can use your calculator to get this, because this is really what we're after, the interval. And then we get to interpret this interval by using this template. This is the same template that we've been using. We are blank % confident that the true difference in proportion, so this is a new piece because we're looking for the difference in the proportions of, restate the parameter in context, so we have to have the context, is within the interval blank to blank, and usually we do the lower end, comma, the higher end. So, in context to this problem, I would say we are 95% confident that the true difference in proportion of women and men who supported Obama is within the interval negative 0.1583 to 0.0183. If you want to think of this like percents, which to me it makes more sense, would be negative 15.83% to 1.83%. So there's between a negative 15% to about 2% difference in people who supported Obama doing the men minus the women. Since there were fewer men who supported him with the raw numbers, the 120 out of 250, it's going to be negative. It's okay to have a negative interval because you're going from a difference that's negative to a difference that's positive. So this is my conclusion. Now, thinking about going from a negative difference to a positive difference, if I think about this part B, it says, is there convincing evidence that more women than men supported Obama? Well, if I think about my interval from negative 0.1583 to 0.0183, this interval goes from negative to positive. So since it ranges from a negative number to a positive number, there's a chance that there's a difference of 0. Isn't there? If it goes from negative to positive, 0 is in the interval. And this is a big stats concept. If 0 is in the interval, meaning if it goes from negative to positive, and if there's a probability or a possible difference of 0, there's not convincing evidence. There's not convincing evidence of a difference because your interval contains the probability of no difference. Since the interval contains this probability of no difference, it goes from negative to positive, so 0's in the interval, we don't have convincing evidence that more women than men supported Obama overall. So that's a wrap. We use confidence intervals to estimate the true difference in proportions, and if 0 is in the interval, we do not have convincing evidence that there is a difference. So this is section 10.1. Go there to look up more problems, and I'll see you next time.